Hello students, in this video we shall deal with 12th standard differentiation 1.2, the second part. In the first part we had seen some of the questions, but this being a big exercise we have divided it into two parts, so this is the second part. Again I repeat, for these questions we should know all formulae of derivative, all formulae of trigonometry and all formulae of inverse trigonometry too. If you don't learn those formulae, then these questions you cannot solve these questions. So I hope you will learn the list first and then you attempt these questions. Now see, this is cos inverse of something which is algebraic. If we try to use the formula of cos inverse directly, it will be a very difficult and tedious problem, because cos inverse is minus 1 upon under root 1 minus this complete whole square into derivative of this, then division rule and so on. This can be simplified if we know trigonometry, important formulae. 1 minus something square upon 1 plus something square, this is 1 minus tan square theta upon 1 plus tan square theta. So what we do is we put x is equal to tan theta in this problem, and so the problem becomes y is equal to cos inverse of 1 minus tan square theta upon 1 plus tan square theta. Now using trigonometry the question becomes very easy. This is the formula for cos 2 theta. Cos inverse cos gets cancelled, we get 2 theta, and from here we can write theta is equal to tan inverse x. We use this theta over here, and so y can be written as 2 times tan inverse x. So dy by dx is equal to 2 constant, derivative of tan inverse is 1 upon 1 plus x square. That is the result. Is this clear? The second question, again we have 2x upon 1 plus x square. Have we seen trigonometric formula? 2 tan theta upon 1 plus tan square theta. 2 tan theta upon 1 plus tan square theta. So again we put x equal to tan theta. Problem becomes y equal to cos inverse of 2 tan theta upon 1 plus tan square theta. Now what is this formula? This is cos inverse of sin 2 theta. Now this is sin, we convert it to cos, complementary ratios. Sin theta can be written as cos of pi by 2 minus theta. So cos inverse cos gets cancelled and we get pi by 2 minus 2 theta, and theta can be replaced as theta equal to tan inverse x, and so we get y equal to pi by 2 minus 2 times tan inverse x, and derivative will give dy by dx is equal to 0 minus 2 upon derivative of tan inverse is 1 plus x square. So this is the result. So students, we start the third question. Try to solve it on your own. I give you 2 minutes. Any hint? No? Let me solve. Now see, this is negative powers. We can convert negative into positive. So e raised to minus x will become 1 upon e raised to x. And then we have to cross multiply and we get e raised to x whole square minus 1 upon e raised to x whole square plus 1. Then we will have to use the formula for inverse trigonometry, because there is no such formula. Formula is 1 minus tan square theta. So instead of this, we make a small adjustment. What we do is we divide each term by e raised to x, so that we get 1 over here. Dividing numerator, denominator by e raised to x, check what do we get. Y equal to cos inverse of 1 minus e raised to minus x upon e raised to x, will be e raised to minus x whole square upon 1 plus e raised to minus x whole square. Understood this? Divide this by e raised to x. So we get e raised to minus x upon e raised to x. That is e raised to minus x into e raised to minus x. That is e raised to minus x whole square. So we have written this term. Now this is trigonometric formula. So we have to put e raised to minus x is equal to tan theta. So what do we get? Y equal to cos inverse 1 minus tan square theta upon 1 plus tan square theta, again cos 2 theta. So we get cos inverse of cos 2 theta. Cos inverse cos gets cancelled, we get 2 theta. And from here we get theta equal to tan inverse of e raised to minus x. And so derivative 2 times tan inverse e raised to minus x. 2 theta is 2 times tan inverse e raised to minus x. And now derivative is dy by dx equal to 2 constant. Derivative of tan inverse is 1 upon 1 plus x square. In place of x we have e raised to minus x. So we use the chain rule. Derivative of e raised to minus x. Derivative of e raised to x is e raised to x. So derivative of e raised to minus x is e raised to minus x. Again chain rule, into derivative of minus x is minus 1. So answer becomes minus 2 times e raised to minus x upon 1 plus e raised to minus x whole square. This is the derivative. Question number 4. What we can do? Again, trigonometric formula, 2 tan theta upon 1 minus tan square theta is tan 2 theta. Now we want here 1 minus tan square theta. To write this term in terms of square, we write it as 2 times x raised to 5 by 2 upon 1 minus x raised to 5 by 2 square. And now we put x raised to 5 by 2 equal to tan theta, and so we get y equal to tan inverse of 2 tan theta upon 1 minus tan square theta. What is 2 tan theta upon 1 minus tan square theta? Trigonometry formula. This is tan 2 theta. Tan inverse tan gets cancelled, 2 theta, and theta can be written as tan inverse of x raised to 5 by 2. So 2 times tan inverse of x raised to 5 by 2. This is y. So derivative dy by dx, 2 constant. Derivative of tan inverse is 1 upon 1 plus x raised to 5 by 2 square, chain rule, into derivative of x raised to 5 by 2 is 5 by 2, x raised to 5 by 2 minus 1 is 3 by 2. This 2 gets cancelled, and in the answer we get 5 times x raised to 3 by 2 upon x raised to 5 by 2 square. This 2 will get cancelled, 1 plus x raised to 5. This is the answer. Now students, for question number 5 onwards, we should know formula for inverse trigonometry. Tan inverse A plus tan inverse B is equal to tan inverse A plus B upon 1 minus AB, and if this is minus, we get A minus B upon 1 plus AB. So tan inverse A plus tan inverse B is equal to tan inverse A plus B upon 1 minus AB. If plus is interchanged by minus, then here interchange of plus and minus. Now this is tan inverse. In this denominator we have 1. So we have this 1 over here. So now we adjust the term such that in the denominator there is a product, and if there is minus in the denominator, in the numerator there is plus. This is minus in the denominator. So in the numerator there should be addition. So we have addition of 2 terms and their multiplication over here. Can we see 2 terms? 5 into 3, 5 plus 3, 5x plus 3x. So y can be written directly as making some adjustment 5x plus 3x upon 1 minus 5x into 3x. Tan inverse a plus b upon 1 minus ab is tan inverse a plus tan inverse b. So this is equal to tan inverse of 5x plus tan inverse 3x, and problem becomes easy now. Derivative of tan inverse 5x is 1 upon 1 plus 5x whole square, chain rule. Derivative of 5x is 5. 1 upon 1 plus 3x whole square, derivative of 3x is 3, and so answer is 5 upon 1 plus 25x square plus 3 upon 1 plus 9x square. This is dy by dx. This should not be y, this should be dy by dx. We have taken derivative. This is y. So this is fifth answer. Now students, in the sixth question we have cot inverse, but we know inverse formulae. Cot inverse can be written as reciprocal tan inverse, and this bracket will be taken reciprocal. So what do we get? Y equal to, in place of cot inverse we write tan inverse, and reciprocal of the term inside the bracket, that is 2x upon 1 plus 35x square. Now again, denominator is 1 plus, so there should be subtraction in the numerator. So we want two factors whose subtraction is 2x and product is 35x square. Can we think of 7 and 5? So we can directly write the answer 7x minus 5x, 1 plus 7x into 5x, and that is the formula tan inverse of 7x minus tan inverse of 5x. This is y using this formula, and now the derivative dy by dx is equal to 1 upon 1 plus 7x whole square is 49x square into derivative of 7x is 7 minus 1 upon 1 plus 5x whole square is 25x square, derivative of 5x is 5. So this is our answer. Let us move on to question number 7. Now we need some adjustment over there. Check in the numerator we have tan inverse of 2 times x plus 2. Now this can be written as tan inverse of 2 raised to x into 2 square. A raised to m plus n equal to a raised to m into a raised to n upon, and this we can write as 1 minus 3 times. Now this 4 raised to x can be written as 2 raised to x square. Is it clear? 2 raised to x, this is also 2 raised to x. Now check again, this becomes tan inverse. This is 1 minus 3 times something square. We may have to use the substitutions, or that we can do in the last step. Let us see what we can solve. We can write this as 4 times 2 raised to x, 1 minus 3 times 2 raised to x square. Now 1 minus, this is product of two numbers 3. Since this is minus, this should be addition of two numbers. So 4 can be written as 1 plus 3. It is 1 times 2 raised to x plus 3 times 2 raised to x. So let us see what we can write. Tan inverse of 2 raised to x plus 3 times 2 raised to x upon 1 minus, we can write this as 2 raised to x into 3 times 2 raised to x. Check this product, 3 times 2 raised to x whole square. So this is the adjustment, and now we can write this using this formula, tan inverse of 2 raised to x plus tan inverse of 3 times 2 raised to x. This is y. Now derivative dy by dx. Derivative of tan inverse is 1 upon 1 plus 2 raised to x whole square into derivative of 2 raised to x is 2 raised to x log 2 plus 1 upon 1 plus 3 times 2 raised to x whole square into derivative of 3 times 2 raised to x is 3 constant, derivative of 2 raised to x is 2 raised to x log 2. Now see students, in both the terms we are getting 2 raised to x log 2, so it is common, and in the bracket we can write 1 upon 1 plus 2 raised to 2x plus 3 upon 1 plus 9 into 2 raised to 2x. So this is the answer. You can also write 2 raised to 2x as 4 raised to x, or even if you write this is correct. So this is question number 7. I hope you have understood. Watch it again, try to understand and practice it on your own so that you can solve it later. Now similar adjustment will be there for the next question also. 2x plus 1 we can see over there. So what do we write? Y equal to tan inverse 2 raised to x as it is, 1 plus, we can write this as 2 raised to 2x into 2 raised to 1, that is 2. So this is 2 times 2 raised to x. This is addition. So in the numerator we want subtraction of two terms. So we try to adjust the numerator. This 2 raised to 2x is 2 raised to x whole square. There is 2 raised to x in the numerator. So each term must contain 2 raised to x. So can we write 2 times 2 raised to x minus 1 times 2 raised to x upon 1 plus, this term can be written as 2 times 2 raised to x into 2 raised to x. Check whether we get this denominator. 2 into 2 raised to x square is 2 raised to 2x, and that is equal to tan inverse of 2 times 2 raised to x minus tan inverse of 2 raised to x. This is y, and now derivative dy by dx. Derivative of tan inverse is 1 upon 1 plus 2 times 2 raised to x square into derivative of 2 times 2 raised to x, 2 constant. Derivative of 2 raised to x is 2 raised to x log 2 minus tan inverse derivative is 1 upon 1 plus 2 raised to x square into derivative of 2 raised to x is 2 raised to x log 2. So again in both the terms we get 2 raised to x log 2 common, and in the bracket we can write 2 upon 1 plus 4 into 2 raised to x square, or we can write 4 raised to x. Is this clear? Minus 2 raised to x log 2 is common. We can write 1 upon 1 plus 2 raised to x square is 4 raised to x. So this is the answer for question number 8. Students, I suppose you have understood these problems. There are many problems for practice. Practice them well. Now see the last question.